Hello everybody. In this video, I am looking at two different things, hierarchical data and Choropleth maps. These two don't typically go together, but they're both under the umbrella of Plotly plots. So I thought rather than break it into two kind of minute videos, I would just cover both in one video. It's pretty straightforward and pretty simple, so I didn't want to just have like a 2 or 3 minute video at each. I thought I'd just combine it and then explain both. Again, the overlap is pretty minimal, but there are some similarities. And again, everything is in the Plotly world, so I think it's pretty interesting and pretty useful stuff. So what's hierarchical data? Basically, it's multiple layers or levels of data that usually have, basically always have a parent-child relationship. So the parent is sort of the feature that occurs over and over multiple times, and then it's broken down into more finite details at the child level, right? So there'll be several child levels for one parent, and the hierarchy represents how data is grouped or categorized between the parent and a child. So let's look at an example right here. This file is located on my desktop. I'm going to import it. Hit Control Enter and refresh this Jupyter notebook. I'll share all the data sources so you can do this for yourself. But I'm going to make this also very generic. So if you don't have this data and you don't want to go to this data source, I'll share the source with you if you want to do this. Anything that has a parent-child relationship, you can do hierarchical plotting with it. So I went ahead and loaded the data. You can see you have indent level, which just looks like a counter to me. Starts at 0, goes up incrementally. So that's kind of useful, kind of nonsense. It's just rows, all right, counting rows. But the most interesting thing here are the items and groups, and then the weight of each item, and then the parent. So you can see obviously the parent-child relationship here, and then the weight or the intensity or sort of like the numerical the numerical weight assigned to each child item by the parent parent item, right? So we'll go ahead. We're using Plotly right here, and this is called a sunburst chart. It's super easy. You feed in the data frame. That's what we just loaded, and the path will be the parent and the item or group because that's the child, and then the values will be the weight. So you'll see when I run this here, I'll run it just to refresh it, just so you can see that this is not some static thing. It's very dynamic. It refreshes quickly and easily. You can see the parent-child relationship, right? And the weights are basically like the, how would you call it? The amount of space for each section here, right? So you can see housing. I love these Plotly plots because you can zoom in and you can see the all the details behind it. So you can see label is housing, parent is all items, right? And parent is in the middle, and then the child is on the outside, and you can see the value too. So 42.38. So that's why it's the biggest space. This has 15.16. This one looks about the same, maybe slightly smaller, 15.15. Okay, so these are going in descending order down to the smallest, which is 2.63. So cumulatively, these add up to 100%, and then broken down by child, you can see the distribution here. So that's all items. When you click on it, it automatically expands and then contracts when you click again. So here we have, looks like shelter. My eyes are not too good, guys. Sorry, my eyesight it's fading. 24.26 here, 7.6 here, and let me try to get a better color. Maybe some orange or something might be easier to read. But you can see the functionality and how everything works out, right? So the parent is in the middle, the child is on the outside, and you can see the weights for each one, right? So pretty interactive. You can see the hierarchy clearly and easily. That is a sunburst chart. This is a tree map. Let me refresh this just so you can see in real time. This is not like some made-up thing. This is being created dynamically. You can see here, again, the parent-child relationship. We see shelter. We see all the details here. Food. The weight is 14.119. Here's the category label, and then the parent and child, right? So the same rendering that we saw above, just represented differently. This is more of a square sort of plot, and then this above is obviously like a pie chart or a circle chart, right? So if we go down again, we can see another type of chart. This is called a histogram or dendrogram. Sorry, it's a dendrogram chart. I will refresh it so you can see how it works. So in this case, again, you'll see the parent-child relationship. So you can see it's pretty busy down there. It's not adding a lot of value. It's actually kind of confusing. I wouldn't present this to a client just because we can't even tell what's really going on. You can see the hierarchy, sort of like the parent level and the child level, but it's just too busy. But you know what? I tried it. Didn't really work, but that's fine. We have two working options directly above the tree map and then the sunburst chart. So we can see how these hierarchies work. And we have two plots that work, one that doesn't. We'll just go with the two that work well. So let's switch gears at this point and look at a Choropleth map. This type of map uses colors and shading and intensities representing darker or lighter and a predefined geographical format. So you can see shapes of states, you can see counties within the United States, you can see borders of countries across the world. So there's a lot of applications to represent geographical areas, represent color intensities for different areas. You have the legend, which breaks down the quantitative measure of the colors, and the maps overall are very easy to interpret and to understand. Let me go ahead and load this data. This comes dynamically from the web. Control Enter to run it. Okay, so we have our country, continent, year born. This is life expectancy now. Or the year of the study. Okay, I'm sorry. This is the year of the study. Life expectancy, overall population, GDP, ISO alpha. It looks like an abbreviation of the country, and ISO numbers. So it probably is an ID for the country. Not too sure. Those don't matter. Okay. All we need is this Choropleth from Plotly again, like we saw before with the hierarchical data. Plotly is a very dynamic library that has all kinds of options for bar charts, pie charts. Without scatter plots, histograms, whatever you can imagine, they have it, right? So it's very useful. Those are probably some of the more popular types of charts. The ones I'm showing you now with the sunburst, the tree map, the Choropleth. These are not quite as popular, I think, but depending on the application, it can be very, very useful. So now we're looking at the data frame. There's only a couple items that you have to feed in here. The location is ISO alpha. Color is life expectancy, hover name is country, and over here we have the interpretation of the chart. So the lighter colors have longer life expectancies and darker have shorter life expectancies. So the great thing about these Plotly maps is they're very dynamic. You can zoom in, okay, get the details for these countries. Here's Europe over here. Let's zoom in on that. That's pretty interesting. France, Switzerland, life expectancy 69.2. Germany, 67.5, pretty similar. France, pretty much the same thing, 67.4. Spain and Portugal. Okay. So, yeah, so that's pretty cool what you can do with these with these Choropleth plots, right? You can see every country in the world and life expectancy for each one. Look at the documentation for this Plotly Choropleth. Just Google it. It's going to have all the documentation, what you need to feed in there. Very simple and very easy to set this up and run it. You just feed in the relevant fields here, and you're up and running. Now, here's global population, similar thing. ISO alpha, color now is the population. Hover name is the country. And again, we get a rendering of all the countries in the world. We can zoom in, we can zoom out. The mouse, the pop-up on the mouse here represents the details behind the map. So super intuitive, super useful. I really like these Choropleth maps. Let's look at another example here. This has code, state, and category. Okay, so load the data. It looks like, okay, related to agriculture, food, something like that. Again, we're using Plotly, and now we're doing plots by state. I'll go ahead and hit Control Enter and refresh it just so you can see this is dynamic and working in real time. Okay, millions of US dollars exports. You know what? This totally makes sense to me. California is a huge export of agriculture. Anything from lettuce, oranges, any kind of citrus to avocados, you name it. A huge agricultural exporter. And you look over here in Maine, not so much, right? The lighter colors have less exports, 278 in Maine compared to 1.16,000. I think this is by per GDP, per capita, something like that. But you can see the relative scale here, and then again, you can zoom in if you need more details, and then zoom out. So very interactive, very intuitive. Really like these Choropleth maps. Now, the FIPS Federal Information Processing Standards is a further granular breakdown of all the state plots or state borders into county plots. So this is pretty cool. When we load this, we have to get the county data. Like in that last example, we simply didn't have it. If you don't have the data, you can't use it. But when you have data at the county level, you can do some really cool plotting here. So I'm going to import this FIPS data and go ahead and look at, let's see here, let's go look at this FIPS and then US unemployment. So this is unemployment data. Control Enter to run it. Okay, so we have the FIPS county data. These are all the counties around the US, and we have the unemployment. Go ahead and plot it, and we have a super nice looking, pretty sexy, dare I say it, map of all of the counties in all the states in the US. Okay, so this is, again, Plotly. Mouse over, you get the employment rates, the FIP county code. The largest one is in the whole United States is San Bernardino. I used to live here many years ago, so I know that by fact. That's the largest county in the United States. But then all the counties here, you have all the details for everything. So pretty cool. Again, you can zoom in, get all the details for each one. I see Illinois here. It looks like Wisconsin just above that. So yeah, these Choropleth maps are intuitive, useful, easy to set up, super easy to use. And all you have to do is plug in a couple of variables right here, depending on what it's asking for. The color is the unemployment rate. The location is FIPS. It's pretty intuitive. Just try it, think about it, do some Googling on this Choropleth, look at the documentation, and I think you're going to find a lot of use cases for these types of maps. So last one I'll show you is right here, by state. So not as granular as what we saw before, but this is IRS data now, adjusted gross income by state, and you can see the darker colors actually represent higher incomes, and the lighter colors represent lower incomes. And again, this should be pretty intuitive. Like the high income states are New York, Texas, California, Illinois, a little bit because of Chicago, Florida, a little bit too because of Miami. But that's it. Those are probably the big five, and the rest are in between or somewhat low. Probably Alaska's on the lower end. Any of these lighter colors are going to be lower. New Hampshire, Maine, Vermont, right? So here's all the data sources. I'm going to post this this file. I'm going to save this Jupyter Notebook as an HTML file. I'm going to share that when I share the video, so you'll have all the source code. You can copy paste it into your own Jupyter Notebook, run it, and you're in business. You're good to go. I tried to make this dynamic, scalable. You would plug in your own data, get the results that you need for your specific task, whatever you're doing. But I tried to make it as generic as I could to illustrate the point, number one, but also to make it easy to plug in your own data set and get up to speed with this stuff super quickly. Okay, so hopefully you learned a thing or two today. Thanks for your time. Have a great day. Bye.